Today we're going to start talking about parabolas, and the first thing we need to discuss is the formal definition of a parabola. So a parabola is the set of all points in a plane that are equidistant from a fixed line, and that line is called the directrix, and a fixed point called the focus that's not on the line. So if we look at the parabola right here, which is a parabola that we're used to, something of the form y equals x squared. We have a focus, we have our vertex, and now we have a directrix. The distance from the vertex to the focus, or the distance from the vertex to the directrix, is p. So that's p. And we get the p-value from the equation. Normally what happens is there's a coefficient in front of the x squared or the y squared, and that coefficient is 4p. Or if we had it in our normal notation where we have y equals ax squared, this would be 1 over 4p x squared. If our parabola faces left and right, then instead of it being x squared, we'll have y squared. So we would have x equals y squared. We still have a directrix. We still have our normal vertex and our focus. And just because we've rotated it 90 degrees doesn't change the fact that this distance is still p and this distance from the vertex to the directrix is p. And again, in the equation, we'll have x equals basically ay squared, so 1 over 4p again here. The standard form of the equations of parabolas are shown below in that chart. And we're not necessarily used to this because this is a standard form for conic sections. In the past, we've said that the standard form of a quadratic is y equals ax squared plus bx plus c. But now we're looking at conic sections. And so what happens is if we have our normal x squared, we can transform this equation into vertex form, which is a little bit more of what we're used to. We would divide by 4p, so we'd get 1 over 4p times x minus h squared. We'd add the k like we're used to, and that's y. And that's the vertex form we're used to seeing, right, where we have y equals a times the quantity x minus h squared plus k. So that's vertex form. The only thing that changes if our parabolas go left and right is the k goes in with the y and the h stays with the x, but the y is what's squared, so you can see that here. And if you want, you can change that into vertex form as well. I'll go over here. You would get x equals 1 over 4p times the quantity y minus k squared plus h. In either case, your vertex is hk, and then you can find the focus and the directrix from there. The other thing that parabolas had that we didn't necessarily know about is a latus rectum, which is a line segment that passes through the focus, is parallel to the directrix, and has endpoints on the parabola. And the length of it is 4p. So here's our latus rectum, okay, because here's our focus, and we know that that whole distance is 4p, so this is 2p, and that's 2p. On either side of the axis of symmetry. Okay. Occasionally we'll use that idea to help find other points on the graph. So now let's go ahead and start graphing. We're going to find the focus and the directrix of the parabola given by y squared equals 12x, and then we're going to graph it. We're more comfortable with the idea that x equals 1 over 12y squared. So this is a parabola that has a vertex at 0, 0. And we know that 4p equals 12, which means p equals 3. So then we can go ahead and graph this. We'll draw on our x and our y-axis. We'll mark our vertex. Since y is squared, we know that this parabola opens left or right. And since 1/12 is greater than 0, this is actually going to open right. So our focus will be 3 units to the right of our vertex. So our focus is right here. And the directrix is going to be 3 units to the left. And then we can see, as we dot those in, that the parabola would have to open to the right. So x equals -3 is the directrix. The focus is 3, 0. And then from our focus, we can use the lattice rectum to find another set of points. So we know that we have to go up 2p and down 2p from our focus. So we'll go up 6 and down 6. And then that gives us 3 points to be able to graph our parabola and have it open to the right. Okay, for the second example, we're given the quantity x minus 3 squared equals 8 times the quantity y plus 1. If we put that in vertex form, then we would have y equals 1/8 times the quantity x minus 3 squared minus 1. So our vertex is at 3, -1. And we get a p-value, well, 4p is equal to 8. So p is equal to 2. And since x is squared, we know that this opens up or down. But since 1/8 is greater than 0, we're going to open up. And that'll help us plot our focus and our directrix. So we'll go ahead and put our x and our y-axis on the grid. We'll plot our vertex of 3, -1. Okay, since this opens up, we know that our focus will be 2 units up from our vertex. So our focus will be right there. And our directrix will be 2 units down. And it'll be a horizontal line this time. So our directrix is y equals -3. And our focus is 3, 1. From our focus, we can count 2p, so 2 times 2, 4 units out in either direction along the lattice rectum so that we can get more points to graph. So. All right, and then we can connect the points. And we're good. All right, so for example number 3, we're asked to write the standard form of the parabola. And they give us some information, so we'll go ahead and put it on the graph just so we can see what's going on. So we have a focus of 5, 0, and a directrix of x equals -5. So that actually tells us a lot of information. First, we know that this is going to be a y squared and that it's going to open right. We also know that the vertex is halfway between the directrix and the focus, so and along the same axis of symmetry as the focus. So that gives us a center or a vertex of 0, 0. And it also tells us this distance here, which is p, is equal to 5. So we can say that x equals 1 over 4 times 5, or 20, y squared. But since this is a standard form of a conic, we want to get the y squared term by itself. So 20x equals y squared. In the next example, we're going to have to complete the square to find the vertex. So we're going to leave our y squared terms on one side and move everything else over to the other side. So we'll get negative 12x plus 23. To complete the square for y squared plus 2y, we need to add 1 to both sides. So we would get y plus 1, the quantity squared, equals negative 12x plus 24. Now we can go ahead and put this into the vertex form that we're comfortable with by solving for x. So we would get y plus 1 squared minus 24 equals negative 12x, which means that x equals negative 1/12 times the quantity xy plus 1 squared plus 2. So that means that our vertex is going to be at 2, negative 1. Because the y squared, or because the y is squared, this is going to open left or right. It's actually going to open left because the coefficient is negative. And we know that p is equal to 3 because 12 is equal to 4p. So then we can go ahead and graph this. Put on our axes. All right, we'll go to our vertex. So that's 2, negative 1. And then the directrix will be 3 units to the right. And the equation of that line is x equals 5. Our focus will be 3 units to the left. So our focus is at negative 1, 1. And then from our focus, we can go up and down 2p to get our other points. So we'll go up 6 and down 6. And there is our parabola. And we have found everything that we need. All right, for the last one, we have a word problem. We have a parabolic television dish antenna, and we know that the receiver, so we'll draw a little parabola, and the receiver is 3.5 feet from the vertex. And is located at the focus. So here's the focus. There's our vertex. We want to find an equation of the parabola used to shape the dish of the reflector, and we want to assume that the vertex is on the origin. So since the distance from the focus to the vertex is 3.5, we know that p equals 3.5, which means that 4p will equal 14. This is our traditional y equals x squared, so it would be y equals 1 over 14 x squared. But we want to put it in the conic sections, the conic sections standard form. So we'll say 14y equals x squared. All right, as always, let me know if you have any questions.